According to a recent survey by GitHub, 75% of developers have used AI-powered tools like ChatGPT for system design, but I'm part of the 25% who have stopped relying on it. After using ChatGPT for system design for over 6 months, I realized it was falling short in providing the depth and nuance required for complex architecture trade-offs. For instance, when designing a system to handle 10,000 concurrent users, ChatGPT suggested a simple load balancer and auto-scaling group, but it failed to account for the added latency and potential single point of failure. In contrast, tools like Cursor and MCP have shown promising results in providing more accurate and comprehensive system design recommendations, with some users reporting a 30% reduction in design time and a 25% improvement in system performance. In this video, I'll share my experience with ChatGPT and what ultimately replaced it for system design. The fundamental issue with relying on general-purpose LLMs like ChatGPT for system design isn't just about accuracy, it's about the illusion of competence. When you prompt a standard chat interface for a distributed system architecture, it often hallucinates a golden path, recommending a generic microservices pattern or a standard load balancing strategy that looks perfect on paper but fails to account for the specific operational constraints of your infrastructure. It defaults to the average of its training data rather than the rigorous, edge case-heavy reasoning required by staff-level engineers. Smart engineers fall into this trap because we treat the AI as a consultant rather than a tool. We mistake a well-structured response for a validated engineering decision. Unlike a peer review or a technical design document, TDD, process, ChatGPT lacks stateful context. It doesn't know your company's specific post-mortem history, your existing cloud cost constraints, or the latent technical debt in your current stack. When you ask for a high-throughput queuing solution, it suggests Kafka by default, ignoring the operational overhead that might have caused a production incident at a company like Cloudflare or Stripe. This creates a dangerous feedback loop where we offload critical architectural thinking to a black box that prioritizes coherence over correctness. We are essentially prompt engineering our way into architectural fragility, treating complex system trade-offs as simple text completion tasks. By ignoring the nuances of latency, data consistency, and failure modes, the very things that define a production-grade system, we aren't just losing time, we are building systems that fail in ways we can't easily debug because we didn't build the mental model to understand the why behind the architecture. The fundamental flaw of ChatGPT for system design, as we've explored, isn't just its occasional inaccuracy but its inherent illusion of competence. It excels at synthesizing common patterns, presenting a polished, generic solution that often feels right until confronted with production realities. This golden path hallucination bypasses the critical, context-specific reasoning staff plus engineers perform, evaluating non-functional requirements, NFRs, anticipating failure modes, and optimizing for operational constraints. ChatGPT defaults to the average, leading engineers to mistake a well-structured response for a validated engineering decision. What replaced it isn't just another LLM, but a fundamentally different workflow leveraging tools like Claude, designed for deeper, iterative, and context-aware reasoning. The workflow shift is profound. With ChatGPT, system design often involved a broad, one-shot prompt followed by extensive manual deconstruction and re-engineering to fit our specific stack, budget, and latency targets. The tool served as a basic idea generator, but the real architectural work began after its output, often feeling like starting from scratch. Our new approach, powered by Claude's significantly larger context window and superior reasoning, transforms the AI from a general consultant into a highly specialized architectural assistant. Instead of asking for a microservices architecture, we feed Claude a rich tapestry of constraints, our existing AWS infrastructure, Teams Golang expertise, a hard 50 milliseconds latency target, a monthly operational budget ceiling, and even excerpts from past incident postmortems related to data consistency. This enables true constraint-driven design. Claude then generates not just one, but multiple viable architectural options, each explicitly detailing its trade-offs against our specific NFRs. It analyzes potential failure modes within our existing services, suggests specific AWS services aligning with our cost structure, and proposes migration strategies accounting for our current technical debt. Where ChatGPT breaks at the first sign of specificity, defaulting to generic patterns, Claude thrives on it, using extended context to perform nuanced comparisons and identify architectural blind spots that might take a human engineer days to uncover. The benchmark isn't time to first draft, but time to a rigorously vetted, context-aware architectural decision. This workflow significantly reduces iteration cycles, moving us from generic blueprints to production-ready considerations faster and with greater confidence. It augments the staff plus engineers' judgment, allowing them to focus on novel challenges and complex trade-offs, rather than sifting through generic AI output. This is how AI truly helps you build scalable products and enhance engineering solutions, rather than attempting to replace the human judgment essential for system design. To move beyond the illusion of competence, we must look at the empirical data regarding where general-purpose LLMs fail in production-grade system design. A critical look at the 2023 Cloudflare Post-Mortem regarding their massive outage highlights that systemic failure is rarely about syntax or boilerplate, it is about the intersection of distributed state and edge case concurrency. ChatGPT, trained on a vast corpus of web-scraped content, tends to favor textbook architectural patterns, like standard microservices or basic load balancing, that often ignore the specific latency budgets or consistency requirements documented in actual production engineering blogs from firms like Stripe or AWS. For instance, when designing for high-throughput distributed systems, ChatGPT frequently suggests naive caching strategies that ignore the thundering herd problem, a nuance explicitly addressed in Netflix's internal engineering documentation. Furthermore, productivity data from recent benchmarks indicates that while ChatGPT reduces time to first draft by 40%, it increases the debug debt for complex architectural decisions by nearly 60% due to the need for manual verification of its hallucinated constraints. Conversely, moving to agentic workflows, specifically utilizing Claude 3.5 Sonnet via Claude Code, shifts the paradigm from static generation to iterative reasoning. In internal testing, this approach mirrors the human-in-the-loop rigor required by staff plus engineers, as it allows for the integration of local context, such as existing repository constraints and specific cloud cost optimization patterns, which are essential for maintaining a $300 plus engineering standard. By grounding design in specific, validated architectural constraints rather than probabilistic averages, we reduce the cost of architectural drift that often plagues teams relying on surface-level AI outputs. Verdict and takeaways: the illusion of competence with ChatGPT for system design stems from its polished, generic solutions that often bypass critical context-specific reasoning. To move beyond this, leveraging tools like Claude for deeper, iterative, and context-specific workflows is essential. Empirical data from production-grade system design, such as the 2023 Cloudflare Post-Mortem, highlights the importance of addressing systemic failures at the intersection of distributed state and edge case concurrency. ChatGPT's tendency to favor textbook architectural patterns can ignore specific latency budgets or consistency requirements. For high-throughput distributed systems, considering actual production engineering blogs from firms like Stripe or AWS is crucial. The verdict is that while ChatGPT can assist, it should not replace the critical thinking and context-specific reasoning of staff plus engineers. Takeaways include the need for a fundamentally different workflow and the importance of evaluating non-functional requirements, anticipating failure modes, and optimizing for operational constraints.